Hi guys, this video today is going to cover an alternate way to solve log equations, and it may be a lot easier because it's also maybe you can apply the same method in multiple scenarios. So if you would look in your notes, lesson 6.6 on solving log equations, we had this handout, and towards the bottom of this page, and this is on page 3, it was a packet that had two pieces of paper stapled together. Down here at the bottom, there were three methods, and I said to skip the third method. Well, let's go back and look at that third method, because as I've been talking with some different people, it seems like maybe for a lot of you this will be easier. And actually, I'm going to come up here to number these examples also and do the same method that I'm about to teach you. The idea is that for both of these, we're just going to take the log of both sides. Not even use the log base button, but just use that plain old log button on your calculator. So that is on your calculator, that's the button that is next to the 7. I would probably recommend that you do these on a separate piece of notebook paper and maybe just put them in your binder with this page or staple to this page. This is really an optional video, but you're not going to have enough space, I don't think, here to do what we're going to do because we've already filled these in. So let's just go in with what we're going to do. What we're going to do is we're going to take the log of both sides. So the log, just to remind you, the log is an operation, just like adding or subtracting or taking the square root. So like you could take the square root of both sides, or you could take the cube root of both sides, or you could take the fifth root of both sides, or whatever. But you can take the log of both sides. And again, I'm just talking about the regular log, not log base anything. Well, it's log base 10. But on your calculator, just the button that says log. Now, we can't use that button yet because we have this. But remember, we have that rule that says if you have an exponent, bring it out front. And so now let's bring that exponent out front. So we have x times the log of 27 is equal to x plus 5 times the log of 3. And so once again, all I did is I just took this exponent, I brought it out front, and made it into multiplication, which is a property that we've learned with logs that you can do. Now we just put this into our calculator. You just put into your calculator the log of 27. So do that on your calculator. What is the log of 27? Okay, you should have gotten 1.431 for the log of 27, and if you do the log of 3, you get 0.477. Now, let's talk about where to go from here. From here, it's just an equation that you can solve. If you want to distribute this, you can. I actually think it's a little bit shorter if we don't distribute that, if we just divide by 0.477. And if you use the numbers that are on your calculator, in other words, don't round, but just go to your calculator and use that kind of cut and paste function, then when you do this, what you come up with, on the left-hand side, you just get 3x. And on the right-hand side, we get x plus 5. So that's really easy now. We just subtract our x, and we get 2x equals 5, so x equals 5 over 2. And if you look at your paper from when you did this before, a couple of weeks ago, it was the same answer. The difference is, when we did this before, we broke up our 27 into 3 to the third, and we did it that way. But this is just a more straightforward way to do it. Let's do the same thing on number 2. Again, when we did this before, we took this 16 and we make it 2 to the fourth. But we can make it a really simpler problem, more straightforward. So I'm just going to take the log of both sides, and then I'm going to take my power and put it in front. And now you can either make these into decimals at this point, you could divide by log 2 at this point, whatever. Maybe just for this one, since that's what we did before, let's stick with a decimal for now. So let's find the decimal value for log of 2 and a decimal value for log of 16. Okay, log of 2 is 0.301, log of 16 is 1.204. Now, let's divide by 0.301. Okay, when we divide by 301, again, if you just use the copy-paste function and don't round, that comes out to be exactly 4x. So now we're going to subtract x from both sides and divide by 3, and we get x equals negative 7/3. And again, if you look at your notes from a couple of weeks ago, that's what we came up with there too. It's just a more straightforward way. Let's continue on with that method. We're just going to do 2 more examples here. These last 2 examples are the only ones that really apply still. So again, we did this earlier in option A and B, but we didn't do option C. So that's what I'm going to do now. I do have to subtract my 2, and I need to divide by negative 1. Now, I'm going to take the log of both sides. I need to put my 3x in front. Now, I could find the decimal value, or this is kind of what I was alluding to earlier, you can just divide by the log of 7. So however you want to put that in your calculator, you can take the log of 18, divide by the log of 7, and see what that comes up to. So that, when we divide that, should be 1.485, and then we divide by 3, and we get 0.495. And again, if you look at your notes from before, that should be very, very close to what you came up with before, if not the exact same thing. So another way to do it, just a straightforward, we're going to do, the last one is number 4, and since I've kind of run out of space, I'm going to scoot over here into the middle one, but they're the same problem. This time I have an e. Okay, if I have an e, why don't I do the natural log instead of the regular log? Because like I said a minute ago, you can take the square root of both sides, you can take the cube root of both sides, you can take whatever. So I'm going to take the natural log rather than just the log. But again, the natural log is a button on your calculator that you can do. Okay, I have a power. Power needs to come out front. Okay, the natural log of e is just 1, so I have 1 times x plus 1. And the natural log of 24, I need a decimal value for that. Okay, that was 3.178. I need to subtract 1, and I get my answer of 2.178. One last thing I might address is some people asked a good question when we were studying this unit, and that is, how do I check my answer? On these, you can check it by plugging it back in. Just take that 2.178 and plug it in for the x, and so take e to the 3.178 power and see what you get, and you should get pretty close to 24. Same thing here, just take this 0.495, plug it in for x, work it out, it should come out to be close to negative 16. Okay, that was one that I had intended to teach back when we learned this. Interest of time, I skipped it, but looking back, I think it was the easier way. So you are welcome to use this method on the test, the retake. You're welcome to use it anytime you need to. I will try to post some extra problems that you maybe could work on to use this method. So check Google Classroom for some assignments that you could do as an optional assignment to practice with these type of equations.